Good day, stargazers, and welcome back to Astronomy Daily. I'm Anna.
And I'm Avery, and honestly, this might be our most packed episode of the season so far.
Between a rocket still sitting on a pad in Norway, waiting for its shot at history, a cargo ship that needed a human hand on the wheel, and an entirely different kind of sky show happening over Australian cities last night, today really has it all.
Plus, fresh science off the James Webb Space Telescope that has astronomers questioning everything they thought they knew about lava worlds. We've got news about sealed moon rocks finally giving up their secrets after 50 years. And we'll walk you through one of the busiest weeks in global rocketry in recent memory.
And with less than 2 weeks to go until the most historic human spaceflight in half a century, the countdown to Artemis 2 is well and truly on, though not everyone agrees it should be.
There's a scientist out there saying NASA should hold off. We'll get to that.
Without further ado then, let's dive in.
Let's start with the big one. As of today, NASA is officially targeting April 1st, and yes, we know how that sounds, as the launch date for Artemis 2. The 6-day window runs April 1st through to the 6th.
And just to be clear for anyone just joining us on the show, Artemis 2 is the first time human beings will travel to the vicinity of the moon since Apollo 17 in December 1972. Over 50 years. This is genuinely historic.
4 astronauts aboard the Orion spacecraft launched on the Space Launch System, or SLS, from Kennedy Space Center in Florida. The crew is Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen.
Victor Glover will become the first person of color to travel beyond Earth orbit. Christina Koch will be the first woman, and Jeremy Hansen will be the first non-American citizen to leave low Earth orbit. This mission is full of firsts.
The crew entered quarantine at Johnson Space Center in Houston on March 18th, and they traveled down to Florida on March 27th. From there, it's really just a matter of weather, systems, and that launch window.
Now, the road to get here has had its bumps. There were liquid hydrogen leaks, helium flow issue that caused a rollback to the vehicle assembly building just last month. Engineers found a blocked seal in a cable connecting the rocket to the ground systems. That's fixed now. A successful wet dress rehearsal in late February cleared the way.
And the mission itself, once it launches, will be a 10-day free return trajectory around the moon. They'll swing out to about 5,000 miles beyond the lunar surface, giving the crew and the world a view of the moon that no human has had since Gene Cernan and Harrison Schmitt were there in person.
Now, Avery, you mentioned earlier that not everyone thinks this is the right moment to go.
Yeah, this is a genuinely interesting wrinkle. A researcher at Mexico's National Autonomous University, Victor Velasco Herrera, has published a new analysis suggesting that we are currently in a window of elevated solar superflare risk. His models point to a high activity period running from mid-2025 through to mid-2026, focused on the sun's southern hemisphere. He's recommending NASA delay the mission until the second half of this year at the earliest.
And you can see why he'd be concerned. We've had a G3 geomagnetic storm this week, which we're going to get to in a moment. The sun is extremely active right now.
Right, though NASA has assessed the risks and all teams pulled go for launch. Lori Glaze from NASA's Exploration Systems Directorate said, and I'm paraphrasing, that an incredible amount of work has gone into preparing for this, and they've had very open, transparent discussions about risk posture and mitigation.
So the mission is proceeding, but it does add a certain tension to an already extraordinary story, doesn't it? The sun is at the peak of its 11-year cycle. We're heading back to the moon, and a scientist is saying, "Are you sure you want to do this now?"
Humanity doing bold things anyway. Feels on brand, honestly.
We'll have everything you need to watch the launch live in our show notes. Fingers crossed for April the 1st.
Okay, so speaking of the sun, let's talk about what it's been doing to our skies this week, because it has been spectacular.
A series of coronal mass ejections, or CMEs, that left the sun on March 16th and 18th arrived at Earth around the equinox, and they drove geomagnetic storming to G3 levels on the NOAA scale. That's classified as strong.
And the result were auroras visible from an extraordinary range of latitudes. We're talking reports of vivid displays from New York, London, northern France, even parts of Scotland lit up. And when you see aurora reports from Scotland, you're already dealing with something significant.
But the story closest to home for many of our listeners, the Aurora Australis, was visible across major Australian cities last night. The Australian Bureau of Meteorology issued a severe geomagnetic storm warning, and the southern lights were reported from Melbourne, Sydney, Brisbane, and Adelaide.
That is remarkable. Sydney is not what you'd call a typical aurora viewing destination. If you were outside last night and happened to look south, especially from somewhere with a clear horizon, you may well have caught it.
As of today, March 24th, conditions are easing. We're dropping back to KP 3 to 4, unsettled to active, with a slight chance of isolated G1 minor storm intervals. So there may still be some activity tonight, but the peak has passed.
Now, why is March such a good month for auroras? This is something a lot of people don't know.
It's called the equinox effect. Around the March and September equinoxes, the geometry of Earth's magnetic field relative to the solar wind becomes particularly favorable. The field lines are better aligned to allow charged particles in, which means you can get strong auroral activity even from moderate solar events. Combined with the current solar maximum, the peak of solar cycle 25, and we're living through what could genuinely be the best aurora viewing period until the mid-2030s.
So if you've been meaning to chase the lights, the message from scientists is this is your window. The sun will start winding down from here, and the next solar maximum is over a decade away.
We'll have aurora forecast links in the show notes so you can track what tonight looks like from your location.
I'm sure our producer, who lives in Sydney, will be out and looking up.
Now, let's head into deep space and into one of the most genuinely surprising pieces of planetary science we've seen in a while. James Webb has done it again.
I love a story where the headline is basically, scientists found something they were almost certain couldn't be there.
So the planet in question is called TOI 561b. It's a super-Earth, about twice the mass of our planet, orbiting a star around 280 light-years away. And when we say close to its star, we mean absurdly, almost comically close. It completes a full orbit in just 10.56 hours. A year on this world is shorter than the average working day.
It orbits at 1/40th the distance that Mercury sits from our sun. The day side is in permanent, unrelenting sunlight. The planet is likely tidally locked. Same face always towards the star, same face always in darkness. The surface is thought to be a global ocean of molten rock.
And under those conditions, extreme radiation, extreme heat, extreme proximity to the star, the scientific consensus was that any atmosphere this planet might have once had would have been stripped away long ago. It should be a bare, airless rock.
Except it isn't. A Carnegie Institution's-led team used Webb's near-infrared spectroscope, NIRSPEC, to take the planet's temperature by measuring how much light the system emitted when TOI 561b passed behind its star. If it were a bare rock, the day side should reach something close to 4,900 degrees Fahrenheit, around 2,700 Celsius.
Instead, they measured around 3,200 degrees Fahrenheit or 1,800 Celsius. Still extraordinarily hot, but significantly cooler than expected. And the only explanation that fits the data is that there's an atmosphere up there, redistributing heat from the day side to the night side.
The lead researcher, Johanna Teska at Carnegie Science, described the planet as, and this is a direct quote, really like a wet lava ball. The idea is that there's a feedback loop happening. Volatile gases bubble up from the magma ocean into the atmosphere, while the magma ocean simultaneously pulls some gases back in. It's a strange equilibrium.
What makes this scientifically significant beyond the wow factor is what it tells us about rocky planet evolution. We've assumed for a long time that small, hot, close-in worlds can't hold atmospheres. TOI 561b suggests the reality is more complicated and potentially more interesting.
The team is now analyzing the full dataset to map temperature patterns all the way around the planet and try to narrow down what the atmosphere is actually made of. Water vapor, carbon dioxide, silicate clouds, all on the table.
One of JWST's core missions is finding atmospheres around rocky worlds, because as far as we know, an atmosphere is a prerequisite for life. POI 561b is certainly not habitable in any conventional sense, but understanding how a world this extreme holds on to its air could tell us a great deal about rocky planets that are far more temperate.
There's something genuinely poetic about today's next story. We're going back to December 1972, the last time humans walked on the moon, and discovering that some of what they brought home has been quietly waiting 50 years to tell us something unexpected.
The Apollo Next Generation Sample Analysis Program, or ANXA, was set up specifically for this purpose. When the Apollo astronauts returned from the moon, NASA deliberately sealed some of the samples and set them aside, knowing that future scientists with better tools would be able to extract more from them than the technology of the 1970s ever could.
And that moment has now arrived for a double drive tube pushed into the lunar surface at the Taurus-Litow region by Gene Cernan and Harrison Schmitt during Apollo 17. A team led by James Dodden at Brown University used a technique called secondary ion mass spectrometry to measure sulfur isotopes, and what they found was not what anyone expected.
So, for context, Earth and the Moon have remarkably similar oxygen isotope signatures. Scientists have long assumed that sulfur would follow the same pattern, that the Moon's interior would look chemically similar to Earth's in this regard. Dotton's team expected to confirm that assumption.
Instead, the volcanic material in the sample is strongly depleted in sulfur-33, one of 4 stable sulfur isotopes. The values are, in Dotton's own words, very different from anything we find on Earth. He said he simply wasn't expecting that.
So what does it mean? There are 2 leading explanations, and neither is boring. The first is that this is evidence of very ancient chemistry, sulfur that interacted with ultraviolet light in an early, thin lunar atmosphere billions of years ago. The implication there would be that material somehow cycled from the lunar surface into the mantle, a kind of proto-plate tectonics on a world we don't think has ever had plate tectonics.
The second explanation reaches even further back. The leading theory of the moon's origin is the giant impact. A Mars-sized body called Theia collided with the early Earth, and the debris eventually coalesced into the moon. If Theia had a very different sulfur composition from Earth, that signature might still be locked inside the lunar mantle today, a fingerprint from a collision that happened 4.5 billion years ago.
The data doesn't currently favor one explanation over the other. Dotton is hoping that comparisons with samples from Mars and other planetary bodies will help resolve it. But the broader message is clear. These samples are still yielding genuine surprises decades after they were collected, and there are more sealed Apollo containers still to be opened.
There is something remarkable about the fact that astronauts who have been gone for over 50 years are still, in a very real sense, contributing to our understanding of the solar system.
All right, let's do a lap of the launch pads, because this week is genuinely exceptional for space activity worldwide. NASAspaceflight.com published their weekly preview, and honestly, it reads like a greatest hits of the current space age.
Let's start with what's already happened. SpaceX kicked off the week with the Falcon 9 launch from Vandenberg in California today, Tuesday, carrying 25 Starlink satellites to sun-synchronous orbit. Booster B1081 flying for the 23rd time. Routine at this point, but still remarkable when you say it out loud.
Tomorrow, Wednesday, is arguably the biggest single day in the schedule. ESAR Aerospace's Spectrum rocket has its window at 8 p.m. UTC from Endoya in Norway. We'll talk about that more in the update segment. And at 9:14 a.m. UTC, Rocket Lab's Electron launches from New Zealand's Mahia Peninsula, carrying 2 ESA Celeste satellites. Those are the first of 10 planned navigation demonstration satellites that will test positioning technology in low Earth orbit.
Also Wednesday, China launches a Chang'e 2C from Taiwan, payload classified, which will be that rocket's 87th mission overall. The CZ-2C has been flying since 1982, which puts it in some pretty distinguished company.
Thursday brings another Falcon 9 from Cape Canaveral carrying 29 Starlink satellites, and this one has a record attached. Booster B1067 will be making its 34th flight, setting a new record for Falcon 9 booster reuse. This rocket first flew in June 2021 on a cargo resupply mission to the International Space Station. It's now flying for the 34th time. SpaceX has fundamentally changed what reusability means.
Friday is enormous. China's commercial launch company CAS Space flies its Kinetica 1 solid rocket from Jiuquan with an undisclosed payload, and Roscosmos launches the first ever flight of the Soyuz 5 rocket from Baikonur, also called Irtish. This rocket is Russia's long-awaited replacement for the Zenit family. It carries a mass simulator on this debut flight, launching from a pad that hasn't seen an orbital launch since 2017. Big moment for Russian launch vehicle development.
And the week closes out on Sunday with two more. ULA's Atlas V5 launching 29 Amazon Leo satellites from Cape Canaveral in its powerful 551 configuration, that's 5 solid rocket boosters, for what will be that rocket's 107th overall mission. And SpaceX wraps things up with Transporter 16, a rideshare mission from Vandenberg carrying dozens of small satellites. That will be SpaceX's 40th Falcon 9 launch of 2026 alone, and the 73rd orbital launch attempt worldwide this year.
So, 5 countries, 6 different rockets, Falcon 9, Electron, Spectrum, CZ-2C, Kinetica 1, Soyuz 5, Atlas V5, launching from California, Florida, New Zealand, Norway, 2 sites in China, and Kazakhstan in 1 week.
The age of routine spaceflight is here. It's just also occasionally extraordinary.
Before we wrap, a quick follow-up on 2 stories we covered yesterday, because both have had developments today.
Let's start with the ISS. You'll remember that Russia launched the Progress MS-33 cargo ship, also called Progress 94, on Sunday from the Baikonur Cosmodrome, carrying about 2.5 tons of supplies for the 7-person Expedition 74 crew. Food, fuel, water, oxygen, the good stuff.
But there was a complication. Shortly after launch, one of the spacecraft's 2 Kurs automated docking antennas failed to deploy. The Kurs system is the normal hands-off approach. The ship guides itself in. With only one antenna working, full automation wasn't available.
So this morning, ISS Commander Sergei Kud-Sverchkov took over manually, using the Toru system. That's the telerobotically operated rendezvous system, a control panel inside the Zvezda service module. The spacecraft flew itself to within 200 meters of the station, and from there, Kud-Sverchkov guided it in. Docking was scheduled for 9:34 Eastern Time.
Roscosmos were quick to point out that manual approaches are routinely practiced during cosmonaut training. This was a contingency, not a crisis. And there's a second layer to this story worth noting. This was the first launch from Site 31 at Baikonur since that pad was damaged during the Soyuz MS-28 launch last November, when part of the launch infrastructure collapsed. That pad is Russia's only one capable of sending crewed missions and cargo ships to the ISS. Its return to service is genuinely significant.
We'll keep watching, and with any luck, Progress 94 is safely berthed at the Poisk module as you listen to this.
And on the other story we promised to follow, Isar Aerospace's Spectrum rocket is still on the pad. Weather at Andoya pushed the attempt from Sunday, then from yesterday. The current window is Wednesday night, 8 p.m. to 9 p.m. UTC. We'll have an update in tomorrow's episode.
If it succeeds, it will be the first time a rocket designed, built, and launched from continental European soil has reached orbit. That is a headline we very much want to be able to read. Fingers crossed for ISAR and the whole European space industry.
Again, we'll update any new developments in tomorrow's show.
That is your Astronomy Daily for Tuesday, March 24th. We've got a lot of threads in the air right now. Artemis 2 approaching its launch window, Spectrum waiting for the weather, a sun that doesn't want to sit still. So it's a great time to make sure you're subscribed wherever you get your podcast.
All the sources, links, and reading for today's stories are in the show notes. And if today's episode sparks something for you, whether it's aurora chasing or thinking about those Apollo samples, or just looking up at the moon tonight and doing the maths on April 1st, we'd love to hear from you.
Find us on Twitter and Instagram at Astro Daily Pod, and on TikTok, X, YouTube, and Tumblr at the same handle. The website is astronomydaily.io, and we're proud to be part of the Bytes.com podcast network.
For Anna, I'm Avery. Keep looking up.
And we'll see you tomorrow.